Hi guys, and welcome back to my channel. This is Maria Tina Valeriano, BSCE2C, and we are now in the second part of our engineering utilities to plug. So let's go. For the second part of our Engineering Utilities 2 video, we will now be discussing Module 2, which is Building Electrical Materials and Equipment. Here we have the power generation and transmission. Under the power generation and transmission, we have the power station. It is an industrial facility that houses the prime mover, electrical generator, and auxiliaries for conversion of mechanical energy, chemical energy, and or nuclear energy into electrical energy. It is a facility or system for the generation of electric power. Next, we have building electrical service equipment. Under the building electrical service equipments, we have these service entrance conductors, service entrance, switchboards, panel boards, and building transformer. Let us start with service entrance conductors. When we say service entrance conductors, these are conductors that carry power from the transformer through a metering device to the building service disconnect. These may be overhead or underground. Under the service entrance conductors, we have the service drop. These are overhead wires extend from a pole-mounted distribution transformer to the building service entrance. Next, we have the service lateral. These are underground or buried service entrance conductors. Up next is the service entrance. When we say service entrance, it includes the components that connect the utility supplied wiring to the service disconnect, excluding the utilities metering equipment. When we say service entrance equipment, this receives the service entrance conductors. The service equipment includes a method of measuring power or metering equipment, a method of cutting off power, main disconnect or switchgear, and overcurrent protection devices, which are the circuit breakers or fuses that protect the service entrance conductors. When we say service disconnect, it is a required part of the service entrance equipment that allows electrical service from the utility company to be switched off so that the power is disconnected to the building installation. It is a set of fuses or a circuit breaker that protects the service entrance conductors. Up next are the switchboards and panel boards. First, we have the switchboard. It is a large cabinet or assembly of metal cabinets in which is connected disconnecting switches, overcurrent protection devices such as fuses or circuit breakers, other protective devices, and instruments designed to divide large amounts of electrical current into smaller amounts of current used by electrical equipment. Next is the panel board. It is one or more metal cabinets that serve as a single unit, including buses, automatic overcurrent protection devices such as fuses or circuit breakers. It is equipped with or without switches for the control of light, heat, and power circuits. Up next is the building transformers. Transformers, they are used in transmitting and distributing power from the power plant to a substation. A step-down transformer steps down from the voltage applied to it. A step-up transformer steps up the voltage applied to it. Step-down transformers are typically used in buildings to reduce building system voltages to usable levels. Next is the overcurrent protection. Overcurrent protection devices or OCP devices safeguard a building service or an individual circuit from excessive current flows. It protects the circuit components from severe overheating when current flowing through the circuit reaches an amperage that will cause an excessive or dangerous temperature rise in the conductors. Fuses and circuit breakers serve as automatic overcurrent protection devices. They are designed to open a circuit if the amount of current in amps that flows through the circuit exceeds the OCP device rating. When we say circuit breaker, It is a device designed to open or trip and close a circuit by non-automatic means, and to open the circuit automatically on a predetermined overcurrent without damage to itself when properly applied within its rating. Fuses are overcurrent protective devices with a current opening fusible part that is heated and severed by the passage of overcurrent through it. Here we have the general classification of fuses. First is the cartridge fuse. It is enclosed in an insulating tube. Next is the plug fuse. It is enclosed in porcelain or rubber, commonly used in various electrical appliances. Next is the fuse wire, opened wire of low melting point, commonly used in the safety power switch. Non-time delay fuse. It holds 5 times its rating for 1/4 to 2 seconds. This is not ideal to loads which requires more than 2 seconds to accelerate. And last, the dual element delay fuse time, which holds 5 times rating for 10 minutes. Now we will proceed to the overcurrent protective device ratings. Now the OCPs have 2 current ratings, which are the overcurrent and amperes interrupting current. Overcurrent rating is the highest current it can carry continuously without exceeding a specific temperature limit or without overheating. Now, interrupting currency is the current that a fuse is able to interrupt without being destroyed or causing an electric arc with an acceptable duration. Now in this slide, as you see, we have the standard ampere ratings of fuses and fixed trip circuit breakers based on the PEC or the Philippine Electrical Code. The standard ampere ratings for fuses and inverse time current breakers shall be considered. Here we have the 15, 20, 25, 30, 35, 40, 45, 50, up to 6,000 amperes. Next is the utilization equipment and devices. Utilization equipment. It is a broad category of electrical or electronic machine or instrument designed to perform a specific mechanical, chemical, heating, or lighting function through the use of electrical energy. Now, an electric appliance is an end-use piece of utilization equipment designed to perform a specific function such as cooking, cleaning, cooling, or heating. Electrical device is a component in an electrical system that is designed to carry but not use electricity. These include components such as switches, receptacles, and relays. Now we have the outlets, receptacles, and plugs. When we say outlet, it is the location in a branch circuit where electricity is used. For example, a lighting outlet is the location in a branch circuit where conductors provide power to a light fixture. Receptacle is a female connecting device with slotted contacts. It is installed at an outlet or an equipment where it is intended to easily establish an electrical connection with an inserted plug. Now, plug is a male connecting device that has 2 or more prongs that are inserted into a receptacle to connect to an electrical circuit. Up next, we have the switches. Now, a switch is an electrical component that can break an electrical circuit, interrupting the current or diverting it from one conductor to another. Here we have the switches and its symbol. For the single pole, we have the S. For the duplex, we have S sub 2. And for the triplex, we have S sub 3. A double pole, we have an S sub 2P. And a 3-pole, we have an S sub 3P. And the 3-way or 4-way, we have the S sub 3W or the S sub 4W. An automatic door, we have the S sub AD. And a key operated, we have the S sub K. For the master selector, we have S sub M. And for the remote control, we have the S sub. In this slide, we see the switches and its descriptions and its symbols. We have the SPST or the single pole single throw, the SPDT or the single pole double throw, for the DPST, which is the double pole single throw, and the DPDT, or the double pole double throw. And here are its corresponding symbols. In the previous slide, we saw the switches for lamp controls. Now we will discuss it one by one. First, we have the SPST, or the single pole single throw switch. It is used to control a single or group of lamps from one location. The switch has only two terminals. Now the SPDT, or the single pole double throw or three-way switch, is used to control a single lamp from two different locations. The switch has three terminals. Next is the four-way switch. This is used to control a single or group of lamps from one location. The switch has only two terminals. For lamps control from three or more locations, there should always be two three-way switches and the rest are four-way switches. For four locations, two three-way switches and two four-way switches. For five locations, two three-way switches and three four-way switches. For six locations, there would be two three-way switches and four four-way switches. Now here we have the disconnects. Now, disconnect or safety power switch is a mechanical switching device used to isolate a circuit or an equipment from the supply side. It could either be fused or non-fused type. Now, the standard ratings of disconnects in amperes are 30, 60, 100, 200, 400, 600, 800, 1200, 1400, 1600, and 1800. Next, we have the conductors. First is the electrical conductor. It is any material that conducts electrical current. Electrical conductors are either solid or stranded. Solid conductors are a single solid length of conductor called a wire. Stranded conductors consist of smaller wire strands. Conductors may be insulated or bare. Next is the bus bar. This serves as a common connection for two or more electrical circuits. Typically, solid bars used for power distribution. Bus bars are either flat strips or hollow tubes. Cable contains more than one conductor bundled together in a factory assembly of wires. An outer sheathing encases and protects the conductors, simplifying installation of multiple wiring. We also have insulated conductor. It is a conductor encased within material of composition or thickness recognized by the PEC as electrical insulation. We also have the covered conductor. This is a conductor encased within a material of composition or thickness that is not recognized by the PEC as electrical insulation. Bare conductor is a conductor having no covering or electrical insulation or whatsoever. And we have the last one, which is the raceway. It is an enclosed channel for holding wires, cables, or bus bars. Now we proceed to building wires. Thermoplastic cables. These are single insulated conductor of solid or stranded bare annealed high conductivity copper with thermoplastic lead-free insulation of PVC or polyvinyl chloride and protected by a nylon jacket, normally designed to operate up to 600 volts. Now here we have the table of letters and its translation for the wires. Now we have H, which is the maximum allowable temperature of 75 degrees Celsius. If not present, maximum is 60 degrees Celsius. We have double H, which is the maximum allowable temperature of 90 degrees Celsius. Now double HW has a maximum allowable temperature of 90 degrees Celsius for dry locations and 75 degrees Celsius for wet. We also have N, which means nylon sheath around the thermoplastic insulation. R, with this thermoset insulation. T, thermoplastic insulation. W indicates suitable for wet and dry locations. X indicates cross-linked polyethylene thermoset insulation, and -2 indicates allowable temperature of 90 degrees Celsius wet and dry. Now, here is a table of conductor application and insulation. You may take your time to pause the video and understand the contents of the table. Now we have the wire coding and identification. Codes printed on the thermoplastic insulation identify the wires as suitable for use in conduit. So we have here in A, THHN, and in B, there is THWN, as you can see in the picture. We are now approaching at the end. So here we will be discussing about conductor ampacity. Now when you say conductor ampacity, it is the maximum current it can carry continuously without exceeding the temperature limitations of the insulation and sheathing material. Now ampacity is based on the following, which is the wire thickness, the type of conductor material, the insulation and sheathing type, the number of conductors bundled in the sheathing, and the temperature and exposure of the conductor. Now, shown in the video is the ampacity table based on the PEC. Now, you can take your time by pausing the video to read the table. Next, we will be discussing the enclosures and raceways. First is the enclosures. These are electrical boxes and cabinets made of metal or non-metallic materials that provide protection for conductors, connections, controls, and other electrical equipment. Now here we have the enclosures, which is the electrical boxes, junction boxes, and the pole box. Now when you say electrical boxes, these are metal or non-metallic plastic enclosures that hold devices such as switches or outlets and safely permit wiring connections. Boxes are available in 4 primary shapes, which are square, rectangular, octagonal, or round. Next is the junction boxes or the J boxes. These are a special type of electrical box used to enclose conductor connections. Connections are commonly called junctions in the trade. And finally, the pole box. It is a type of junction box that allows access to a raceway for snaking conductors through the raceway. Knockouts in most boxes and other enclosures can be easily removed to allow wiring to enter the box. Now we have the conduit and other raceways. Now a raceway is an enclosed channel used as a conduit, tube, or gutter designed for holding wires, cables, and bus bars. There are many types of conduits, and here, as we see, we have these types. We have the rigid metal conduit, the intermediate metal conduit or the IMC, the electrical metallic tubing or the EMT, the electrical non-metallic tubing or the ENT, the rigid non-metallic conduit, the flexible metal conduit, the liquid tight flexible metal conduit, the liquid tight flexible non-metal conduit, and the cellular concrete floor raceway. Now in this part, here we have again is a conduit size based on the PEC. Here is a table that contains the data, and you may again take time to pause the video and study the table. We also have here the busways and wireways. So when we say busway, it is a standardized factory assembled enclosure consists of outer duct-like housing, bus bars, and insulators. And when you say wireways, or you can also say wire gutters, these are metal sheet or non-metallic, flame-resistant plastic troughs that serve as a housing that encloses and protects conductors. And lastly, we have the electrical motors. We're quite familiar, or we have always heard this word electrical motors. So in homes, electrical motors are found in refrigerators, freezers, dishwashers, kitchen sink waste disposal, portable kitchen appliances, exhaust and ventilation fans, clothes washers and dryers, furnaces, air conditioners, and paddle fans. Now here we have a table of motor ratings based on the PEC. Again, you can pause the video and take your time on reading the data and its equivalents to make it easy for us or for you or for any other people who watch this video about the motor rating. So that ends our second part of the blog in our Engineering Utilities 2, and I hope you guys learned something.